So the last thing that we're going to do with our half angle identities is solve equations. Okay, I'm going to do two. You're going to be kind of surprised how they're very similar, even though they look nothing alike. We're going to solve the first one for 0 to 2 pi, and then we'll solve the next one for infinite answers. Okay, so let's do that first one. Okay, so again, you don't want to have a different period for your answers. So we want to somehow eliminate the tangent x over 2 because that would actually give us a period of pi over 2 rather than pi. Also, we have another problem. We also have this mixed up with sine, which has a period of 2 pi. So we have sine and tangent together. And if we can get rid of that, we want to. Okay, so I'm going to use the version of tangent with cosine on the top. So I'm just going to do a little replacing. And you could replace, with whichever one you want. I just chose this one. Okay, so now I am going to add sine to both sides. So I get something that looks like this. All right, so now I have something like a proportion. So I'm going to cross multiply. 1 times cosine, or excuse me, 1 times 1 minus cosine is simply 1 minus cosine. And then sine x times sine x is sine squared x. Okay, so life is generally easier if you get your equation in terms of one trig ratio. I'm going to choose cosine. Here's why. Okay, if you recall, there's a Pythagorean identity that states cosine squared plus sine squared is equal to 1. If I rearrange that a bit, I get sine squared x is equal to 1 minus cosine squared x. Pretty cool. All right, here we go. So substituting So now I'm going to try to get everything together again because I have a cosine squared. That kind of looks like a quadratic. So I'm going to set equal to 0. So I get cosine squared x. The ones will go to 0 minus cosine x equals 0. Okay, I can solve this by factoring. Okay, so I can factor out a cosine, which seems like a really weird thing to do, but it's not. Okay, you're just dividing something out. Okay, so now set each of your factors equal to 0. Oops. Okay, so I have cosine x equals 0 and then cosine x equals 1. Okay, so I'm going to ask myself, okay, what angles will give me a cosine ratio equal to 0? And what angles will give me a cosine ratio of 1 on the unit circle because I'm only looking from 0 to 2 pi. So that happens, x equals pi over 2 and 3 pi over 2. And then for the 1, it'll happen at 0. Okay, and since we don't include 2 pi, we don't put 2 pi. And then we are finished. Not too bad. Okay, so now we're going to do the next one. Okay. So this one will be sine of x over 2 plus cosine x equals 0. But I want to solve for all solutions. Okay, so again, we want to kind of make our periods match. So I'm going to replace my 1 x over 2, sine x over 2 with the identity. Okay, so now I'm going to put a little trick because I want to get rid of that radical. So to get rid of the radical, I'm going to square it, but before I square it, I'm going to move the cosine over to the other side, because if I don't, then I'm going to wind up with a very, very funny looking binomial, and I don't want to square that. So if I square both sides like this, then I get that. And then negative squared. Okay, well, that looks a whole lot better. I could have gone down a very odd path if I didn't do that. Okay, so now I'm going to times both sides by 2. So I have 1 minus cosine x equals 2 cosine squared x. Now this should look like a quadratic to you. If not, rewrite as 1 minus x equals 2x squared. Just kind of ignore the cosine in your brain, and then if you set it equal to 0, you wind up with something that looks like that. Okay, so we're going to kind of mirror the process. Okay, again, set it equal to 0. Okay, now we're going to factor. Factor over here. Oops. Okay, when we solve by factoring, we set each factor equal to 0. Oops. Okay. Same thing over here. Okay, now we solve. We get x is equal to 1/2, x is equal to -1. And if we were factoring quadratic, we do the same thing. So cosine x equals 1/2, cosine x equals -1. Okay, so where does cosine give you a positive 1/2? That happens at pi over 3. And 5 pi over 3. Okay, quadrant 1 and quadrant 4, where does cosine give you a -1? That happens at pi. Now remember, with this one, we are finding infinite answers. So we're going to add 2 pi times n to each one, because that's the period of my cosine, where n is an integer. Or if you want to get fancy, not that. Like that. Okay. All right. And there you go. All right. Hopefully that was helpful. If not, let me know.